Here we have a submersible vortex pump. So what makes this one interesting is it's designed for a water with particles in or dirtier water, and you've also got a very wide pH range. Everything is stainless steel or ceramic on the internals, and it's plastic at the top, so there isn't something that's going to rust and corrode easily. It's also infuriated for salt water, like seawater applications. For us, what we're mainly interested in is if you have something like rainwater and you want to, say, pump it from one catchment sump over to another one, as these vortex pumps can handle a bit of dust or so fairly easily. And another big advantage of them is they're fairly high flow for relatively low power consumption. So this one we've got here is only a 0.55 rated kilowatt one, but it's rated at 15,000 litres an hour, which is very significant, and about a 0.9 bar pressure, max pressure. So it's just got a electrical level float switch, which you just need to leave enough space for it inside the tank for it to operate, and that can just be locked into the handle to give you the float action. But what makes these interesting is at the bottom here. If you look, the actual input of the pump is lifted quite a bit of a distance from the bottom, so that you can get sediment sitting down at the bottom and not necessarily being caught. And the impeller is sitting in the middle of the pump where the output is on the side. Now, we can't really see that well inside here, but the impeller is about that big, and it's not coming close to the edge of the pump, and is basically creating a vortex inside the pump, which is forcing the water out to the side, which is then where the water feeds out here. So it's an interesting design concept, as in theory the impeller isn't even coming in contact with most of the water. It's literally creating a vortex like you would have when you're draining a bathtub, and it's that effect that's giving you the pumping action. So let's hook it up and see how it actually does. Okay, so here we have the vortex pump running. It's now basically sitting with the valves closed, and we're drawing at about 700 watt, which is a little bit more than the 0.55 kilowatt, so the 550 watt it's rated for, but it's actually very nice and quiet. And we're getting, on where it says 0.9 bar, we're actually there. Yeah, we're at probably about 0.8 bar from the look of that on that pressure gauge. So let's see what happens if we start introducing some flow. There we're at 1,000 litres per hour, and we're still sitting at the 700 watt power draw, and at 1,000 litres per hour we're still at about the 0.8 bar through the piping we have here. Let's see if we turn it up a bit. So there's 3,000 litres an hour. Now we're at 760 watt power draw, so we're drawing a little bit more power, and we're actually still maintaining pressure. Let's see if we take that up to about 6,000 litres an hour. It's at about 0.7 bar, so actually still decent. If you're thinking about it in terms of moving water, 0.7 bar still means you can do a height of about 7 meters change with the pump, which is quite good at this flow rate. And we are drawing 820 watt, so getting quite a bit more power draw than the 550. If we then add some flow, let's see if we take it up to let's take it to about 9,000 litres an hour. There, pressure wise, okay, they were at about 0.6 bar, so 6 meters of height difference at about 9,000 litres an hour. And power draw, power draw we're at 900 watt, so it is using a bit more. It's still very quiet. Then if we set it to about 12,000 litres an hour, then we are dropping pressure a bit. So there we are at Yo, what is that? At about 0.2 bar. So at that point we have very little pressure, but we're definitely getting the flow, getting splashed here from the tank, and we're drawing 970 watts. So we're actually drawing quite a bit more power than it says. Just going to guesstimate it on here quickly. If we up a little bit. Okay, so there we're actually at about the 15,000 liters an hour, which it's rated for. Ew. Pressure gauge is just moving off the base, so not much there, and we're drawing a kilowatt, but you can see it actually still has more to go. If we open it up all the way, yeah, we're definitely getting significant more flow. Okay. So if you haven't got the height to compensate for and you don't need the pressure, then actually it can probably do a lot more than 15,000 liters an hour. But it's impressive. It's nice and quiet. It'll definitely work for the application which we would have in mind for it, to say if your house is at an angle to take your rainwater from one point of a sump over to where your main tank would be. As if you think about it, if we're looking at where did we have 3 bars, so we could probably do easily 10,000 liters an hour at still being able to get quite a few meters of height. So in that case, that would mean, say if you have a 2,500 liter tank, you'd be able to fill that in 15 minutes when it's raining, if you have enough rain. So that honestly is a very, very nice setup.